hands-on hardware training at DWR Machilipatnam had gathered wide attention. He has 18 publications to his credit, and audience, I am very happy, and I urge all the audience to get the many things, your queries from the lecture, and you should be very attentive and get maximum benefit from the lecture. So I now request Dr. Kannan, Bam Kannan, to start his lecture. Okay, thank you.
Very good evening to everybody. It is a nice opportunity rendered upon to me in having a discussion on Doppler weather radars. This, as already our colleagues have informed to you, I was quite lucky to be associated with Doppler radar for a quite long time. And this, as it is going to cover a wide plethora of audience, right from at the student level, and it is going up to the faculty level, we thought that the talk is mixed at certain locations to a higher level. But of course, I kept it as to the possible as a minimal, that all can be going up together. If you have any doubts in between, requesting to kindly raise it then and there. So it becomes easier that the flow will not be getting blocked too. We'll be going through after answering that particular part and we'll be proceeding further. Instead of taking much of your valuable time, I'll be going through this. I thank the DGM, IMD and DGM training section from Pune and my colleagues over there in considering me and giving this opportunity to me. So what is a radar? Literally, we know that radar, the name now most of the people are quite familiar with. It is going for radio detection and ranging, and it has its roots in radio waves. That's why radio detection has come. But most of us, we may be knowing that still we are using micro, it is going to be not exactly the full radio waves. It is only the microwave region. We are going to use it for our radar application. As even in our microwave oven at our home, what we will be using is only the same radar frequencies which we are going to use up with. Initially, the patent started with 1904, as this happened to be having a much of a say on the defense related systems. Most of the things were not literally made available, including the funny part is that the name of radar came only in 1964 when all the rest of the use has been demonstrated. Initially, the purpose of the radar was just people were thinking that during World War, before the enemy aircraft came to attack you, you spread out a ray that they get vanished off. So that assignment was given, and ultimately during that time, such a facility was not available. This was indicated. So that way, Watson Watt has been credited as the father of the radar. Only for the reply, you can see the very first reply was that what was anticipated as a science project, the result was not to the limit. But it is not the case now. Now we can see that over the horizon radars and other things have come where it radiates much of energy. It goes to ionosphere, and even you can have a, a defect created at a very far distance by using ionosphere and over the horizon radar. So initially those things were not feasible, and ultimately even Germans and this British, they were both in loggerheads, and ultimately the entire work has been shifted from British, it went to US, and all the development started happening with. And as we were under the British regime, most of the time the aircraft which they were operating on the eastern coast, they were just pushing off ahead, and near to the Burma and other region where Japan had a higher control, they faced the problem. And these like systems which are very severe, they found that it cannot be achieved directly by using the synaptic charts. So they established the radar network. What they did was that the nose radar of the aircraft was brought to the ground, not one. Dedicatedly, they brought 4. The initial one was at Guskara, and finally it went up to Jorvat and Chauba. You can see that the image to the right, it shows all the regions starting from the Orissa coast, going up to West Bengal, and all the northeast states, as these are the locations where Nor'westers were having much of a say. As you know, Nor'westers are Kalbaishakis, they come from the landward side, it slides down, and there is no much moisture to it, but convective available potential energy is higher. So the lifting mechanism is going to be, but the moisture is not available. Once it comes very closer to the coast, very severe thunderstorms forms, including giving out hail and tornadoes. So tornadoes and these are quite common. And this is guided by the higher level jet stream winds, very strong winds. And these were sometimes carrying the aircraft. All of a sudden, the development was happening. Normally, it happens in the late evening hours, and it used to stand for near around 13 to 14 hours. So this was the one which indulged in bringing the radar for operational forecasting. That's how India had its first operational radar network right in 1942. The same time in Panama, similar experiment was being carried out, but not on the dedicated way as it was done over in India. Only two radars were kept, here four were networked, and each time, as you see here, they said the ground-based radar proved to be the right answer. They found that, and what they did a regularized radar observing, they did a report analysis, as well as they were using it for operational forecasting for the aviation services all along the eastern coast of India, including the radars over the hump region. Why they say is there you can see the Himalayas is quite steep over the Jammu Kashmir region. It flows slightly down, and here again there is a small hump forming right from Sikkim and going all the way there. So that's how they said it as a radar over the hump. And these are the words which now most of you may be looking on similar aspect. Radar showed weather phenomena. Like even now, we have weather radars which is giving to it, but the theoretical background was lagging. It was lagging during those days. Now most of you will be almost on the same state, but there will be quite few who will be having a much higher exposure to it. And seeing to this usefulness without knowing what it is sensing and all those things, as it is giving a signature of an event which could not be tracked with a synaptic chart, they started using the surface-based radars. And ultimately, when Britishers left India, all the war surplus radars were taken over, and India Meteorological Department entered into the foray, and they were developing the radar network. Now you can see that we have near around 34 Doppler weather radars operational. This is taken from the IMD website. Few may be missing, as this whatever reaches there and the data is available to the general public is shown over there. And in the next few years, it will be spanning up to 45. There is a scientific committee which worked upon, and it suggested for 55 radars pan India. If you see in US and all, it is going to be somewhere around 149, serving for most of the purpose. But in ours, in such an efficient way, the radars network were designed that it will be covering most of the region without much of a hardship. And if you see quite carefully along the coast, we have much large number of radars, and these are called cyclone detection radars. As you know, cyclone is one of the disastrous event which causes much of the havoc. Though the satellite will give you a better of the coverage, finally what happens is to the resolution and whatever you do a probing into the system, which at present is not fully available in satellite systems, you don't get at least 10 to 15 minutes update of those kind. Though polar orbiting satellites, they do give, you'll be getting update either once a day or twice a day. If you have multiple polar orbiting satellite passing over that, you may be getting on an increased frequency, but on an average to the same higher temporal resolution as well as spatial resolution. So far without a radar, it's not feasible. Just for you to show that how far we came from. This is the radar of 1957 at Delhi. That time there was a very severe dust storm. The thunderstorm caused hail and much of a damage. And these were the scopes. They say as radar display scopes. Now also we say PPI scope. It is a plan position indicator. Plan position indicator means you stand in the middle and you look all around. Whatever you are looking and finding it out is projected, and that is what it is shown on this circular display. The center is at the radar location, and the range rings indicates how far from the radar these things are getting displayed there. And one more advantage is that we only dictated the world to use a range height indicator scan. You imagine the nose radar of the aircraft is almost stable. When the flight goes in through the pathway, it will be finding whether there is a cloud or not, and accordingly it will be giving us information whether to deviate from the flight track to a certain minimal as advised by the standards, or otherwise not to take off. they'll be just making a recurvature, they'll be landing back. So as such, the radar will not rotate. Now we made a PPA scan, they kept on a bay and they were rotating to get the echoes all around. Now, if the cloud height is to be seen, what is the procedure to be adopted? They thought, and you can see when the mechanical things were so much on the obsolete state, they did a RHA scan to see the cloud base till the top. Of course, this now we are just getting it from the PPA scan by doing a volume scan. And in certain occasions, like the one which you can see to the left, this was done for a purpose when there was a project being carried out in Delhi to show the features of all the things which from a cloud a radar can track. And now saying said about all those things, now whether a radar is the final solution for all those things. As now, you could have already listened to a lecture of satellite and you had a aviation, surface instruments, they might have thought, each people will be impressing upon the usefulness of those. Similar way, radar is useful not on the entire pan scale of weather observation. To a certain limit it will be doing. So the scale of events also got classified by Dr. Ligda. As you know, we told like parallel in India, there was a network formed in Panama. He was the in charge of the Panaman radar network and he was doing this exercise and he classified the event into meso, synoptic and micro. Later on, this classification has been further divided to it and using English alphabets, they went for maso, meso, miso, moso and muso. Now this meso and Meso-Scale, that means starting somewhere from 300 meters or 400 meters onwards, up to 4,000 kilometers, whatever can be observed, there only we can use radars. Why? Like tornadoes or like our dust devils, where the diameter is going to be very lesser, it will be having a velocity couplet, and when I'm sampling by using a radar into the beam, the entire thing gets covered with, it averages out. So it is not feasible at present, but of course in US they demonstrated by using a phased array radar. There the data acquisition time also is quite faster and you can get data at a very span, you can also reduce the resolution to it. So that way if those comes into your reality, we'll be getting. Of course, now India is already advanced in the weather radar technology. We are using solid state power amplifiers for making a phased array radar also. With ISRO, there is a tie-up project where IMD and ISRO is jointly developing to demonstrate a phased array radar by using solid state power amplifiers, which will be coming in near future. So this is on the weather classification. Having said on the classification, okay, that much I am going to get. When satellite I am getting a very larger space, then what are the additional features we'll be getting in the radar? If you see it, this is one of the features. It is a cyclone. You know that only to the radar coverage I'll be seeing. So beyond the radar coverage region, the cyclone features are not seen. But whatever is covered into the cyclone region, you can do the entire profiling. Like I have a thunder cloud. How much water content is into the thunder cloud? How much volume is the cloud? And what is going to be the weight of the equivalent water when everything falls down there? Like nowadays, you can see that flash flood with increasing climate impacts, the flash flood and other things are making a higher impact. So that way, if you see to this left, the cursor which has been kept is on the core of the cyclonic storm, like this alone. That alone you can see how much it is going to be heavier. It is almost going into lakhs of tons in weight, and the water content also you can see to that it is going to be running in plenty. That mass which is declared is the mass of the water into the cell. And if I take a very small cell here, which is spanning hardly 119 kilometers wide and volume of 95 kilometers circle, that also you can see it is going to be 102, 797 tons of water to it. So this much water gets by evaporation, it goes there and sediments out. Now you imagine you are in a metropolitan city and you know this cloud is over about you. That much water, if it falls down, whether the civic mechanism is having that to be drained out into the sea or to store it for future use, if it is missing, then this is going to be leading to flash floods, especially in urban areas. So keeping in this mind, IMD is going up for urban meteorological radars also. We have installed one radar in Chennai with X-band and one in Mumbai with C-band. 4 more radars in Mumbai is going to be put on pilot basis mode. Once this is successful, all rest of the locations also will be getting multiple radars, even though they have another cyclone detection radar. So that is the plan. Now you can see the betterment. By just scanning, I could see the cloud, how much water content to it. Now saying by that, now if a cloud is there, depending upon the cloud feature, the water content is going to be different. Certain time it may be ice. Whether those things we can find it out. Yes, by using a radar, you can categorize the clouds, not on the meteorological term into 10 scales of cloud features, which already someone might have discussed with you. But here what we take it as based to the back received power from the target. For me, the target is going to be cloud, being a radar man. And if I get more of the return, I know the particle distribution into the cloud as well as the numbers are going to be in plenty. And in certain occasions, even if there is a bigger droplet, I'll be getting much more enhanced reflectivity. Accordingly, we classify into very light, moderate, strong, and very strong and extremely strong clouds. By this categorization, the very strong and extreme strong clouds normally bear even hail. So these classifications have been borrowed and it has been published elsewhere. The similar categorization is happening even in intermetrical department. And this is one classical example. We have dual polarization radars. Once we have dual pole radar, what we do is, instead of sampling in one plane of the electromagnetic field, we used to sample on two planes. What is the advantage? Now you imagine that you are walking into a crowd with a stick in your hand. You'll be hitting all the persons to the side. You cannot propagate much. That's how horizontal propagated beam will be suffering much of attenuation, while the vertical beam, you imagine a person carrying a pole like this, he can go smooth and come out. Using these two characteristics of the signals which has been propagated out, we will be in a position to find out what the distribution of the targets and how they belong to. Like heavy rains means it is going to be oblate in shape. Smaller ones, normally they are spherical, and intermediate ones, they become like a prolate, and finally because of the gravitation pull, they become a bun shape or a oblate shape. And if oblate shape is there, we know ZAR value. The differential reflectivity is going to be higher. By this, we can categorize the entire cloud. One is that the cloud categorization we have seen. You have a cloud. Into the cloud, which regions you are having liquid water, which regions you are having melting snow, which regions are containing hail is seen. So that's how we told, no, this image which was occurred was done for a project. You can see the below the categorization very clearly defining that the regions of rain which is shown in green color, the yellow ones are the one which is having solid water, and one on the red is going to be hail, and which is grayed regions which is in the front. These are the gust fronts of the thunder cell which came with, it is categorized with a gray color code. That way, when I am using it, I will know that these locations I need not give a rain alert. It may be because of a gust front, I will be giving a wind related alert. Here I will be having this, and wherever this yellow coloration is there, we can go for a precise hail alert. This already IMD is doing on specific scales. If you go to IMD website, there is a nowcasting web page where using the radar data, all the stations which are closer, they are updating. Yes, sir, please. Any query or something?
You may continue.
Okay. And not only on the clouds, like non-meteorological signatures, like if there is a sea breeze, especially over the persons over the coast, they might have felt it will be so much scorching. Suddenly a sea breeze sets in because of the humid water influx, they'll be feeling a comfort from the heat. So that way, this straight line here, you can see this is observed by a radar. This is sea breeze. And one more thing is the gust front. If you have a very intense thunderstorm, it hits the ground, and at the hitting region, it lifts the dust and other particles, including the bugs. And these attracts the other insects or birds to follow those regions. You will be getting an enhanced reflectivity about the thunder cell. So we know once we get this image, we know this cloud is moving in this direction because of this gust front indicator. Not only those, these gust fronts also they create havoc, so that also needs a specific attention. So this is one event of the gust front which has been shown here. There was aircraft accident which happened in Delhi, and this was carried only because of the gust front. You can see all the clouds are in some other direction. The aircraft had accident at Faridabad. So gust fronts also gathers importance. That's how for our aviation, the one product which in the right corner which you are seeing, it is not given to the public, as these products which you get it from radar are very difficult to validate. We don't have an equivalent observation available except for dye pressure tube anemometer which can capture GUST. Otherwise, even you put a AWS and all those things, you sample it, you will be getting a wind for every minute or less than to that, but GUST capturing is such a difficult exercise as it has to capture not only the wind variation, it should even capture about which direction it went and what is going to be the pressure variation associated with it. That's how we use radars for that purpose, and this product is invariably given to our operational use in aviation sector. Wherever we have a aerodrome office, to that this product is being given with. And this is another feature. I thought that I'll go from the smaller feature to the larger. Initially, we started with gust front, which is very rarely observed because it doesn't contain water, microwaves. It requires water for that to absorb and give back backscattering. Otherwise, oxygen or a polar molecule is required. Sand and other things are non-polar in nature. As such, you should not get a signature. But we get a signature because of non-meteorological targets like bugs, birds, and other things into it. That's how we get it. This microburst is again what we say is suddenly there is a downdraft and it is separated hardly by few meters, and the wind between both the things is differing by more than 10 meters per second. That we say it as a microburst. If the distance is more than 4 kilometers, we say it as a macroburst. So this microburst and macroburst both has a serious impact on the damages. One which you are seeing to the right, which is shown as an animation over here, this is the Purulia case where near around 22 people lost their lives. This is observed by our radar. You can see the cloud spanning down, it is going over, and the frozen picture which you are seeing here, there was a microburst, and here you can see a kidney bean-like pattern. This kidney bean-like pattern, normally we say it as meso-cyclonic circulation. These are slightly larger clouds whose lifetime is quite longer because of the inherent outflow V-notch mechanism. And this, if a couplet happens into it, literally if it is touching to the ground, we say it as a tornado. If it is not there, it is a meso-cyclonic circulation. And during the path, it is going to create a very big hail damage. And this specific case, it was reported could be a tornadic circulation, but all the event happened in the late night. None of the I found observations were there, and in our radar, more than 30 kilometers, if you have it, we can see the velocity couplet, but will not be sure whether it is a tornado or not. The same reason which was told earlier, our beam width is going to be around 1 degree. Irrespective of having such a narrow beam width, these systems are very rare to capture. This is one which our radar captured in Agartala. It is a tornadic event which happened in 2013. To the left, you can see it is at the intense mature stage, and to the right, it is going to be so narrow, which will be covered into a single radar range gate. You cannot find the velocity. But here in this, you can see there is a velocity couplet. Velocity couplet is nothing but the radar gets some few parameters. Like I sent the energy. From the energy, what I will be getting is how much energy came back to me. That I am qualifying it as radar reflectivity factor in the units of dBz. And second thing is I get the velocity using a Doppler radar. If there is a frequency shift or a phase shift to be more proper, how much there was a shift happening. My radar is not moving. Now the cloud, whether it is moving towards or away, will be giving me the velocity. And the third thing is the velocity for each and every bin I used to sample on the same value, there is a variation that I attribute as spectrum width, which normally refers to the turbulence happening at that particular point. By using these three, we can give a precise nowcast to your region of interest. You will come to know whether the cloud was there. Yes, it is going to be moving in this direction. Yes, whether it will last for such a long, you see for the turbulence product, if turbulence is higher, then it is already in the very mature stage. It may not last for more than 10 to 20 minutes. As you know, thunderstorms, the lifestyle is normally 30 to 40 minutes. And if it is going to be a squall line, then only it is going to be higher. So keeping all this in the view, we used to analyze with the velocity product, and velocity is color coded in such a way. The incoming is shown in blue or the cool colors, and the outgoing is going to be the warm colors. or the frequency redshift, the same color we adopted. And this hook-like signature indicates a presence of a tornado, and normally the tornado is on the nose region. It is not somewhere in between, and these are the regions where we hail, and these are the notches which will be showing. I am rushing very fast as the stipulated time is going to reach. If there is something which you wanted a more explanation, we can keep up with. So this is again the theoretical understanding of the tornado. There is going to be uplifting path and there is going to be a downdraft. In between you have all the spread over region and the shooting up region. The cloud will go on shooting up. That's what the study was done for the echo tops. That which was given to the left is the study of the cloud top. If the top is going up and up, we know yes, the severity is still pertaining. And second thing is the presence of the hook echo, and whether you see that whether there is a third body scattering spike. That you send energy, it went there, it hit, without coming to the radar, it went to some other target, it had an interaction and came back to you. Seeing to that, you will be finding out the presence of hail, and this is bounded weak echo. Normally, we assume Rayleigh scattering in our radars. There are certain occasions where Rayleigh scattering doesn't obey. During this region, you will be getting the reflectivity factor lesser. That means the small cavity into this is not void of clouds. Literally, there are big hailstorms, but our radar, it went into the my region, the reflectivity factor is going to go up and down, and this region, the radar could not pick a precise value, as such it has been removed. So that's how it is there. But we radar meteorologists who have been trained for the purpose, we take care of this. Especially when people who are there who have access only to the images, they may be committing a blunder. But mostly the IMD now casting web page, they takes account of all these things and the inferences from the radar meteorologist. That's how it goes up with. So this region also we used to issue warning, and this is the region where a heavy hail warning is normally getting issued. Having said hail, these are the various algorithms adopted either in National Weather Service in US or NextRad NSSL developed algorithms. All these algorithms are even run in IMD, and we did lot of works. And having those algorithms, once you get with the windowing functions and the height of the thermal layers between 0 and 20 degrees known, you can find out how much severe the hail is, what is going to be the maximum expected hail size, whether there is going to be a probability of the hail on that particular thing. Everything can be calculated, and we have papers published which you can see in our Moso. Most of the papers we got it published over there, 2002, 2004, 2010, 2006, and recently. So all these papers are available over there and they have been published. You can see all the signature. This is a kidney bean structure. So probably this may be having, along with that, there will be a rotational vortex, could have been into a tornado. This inferences was given by our Calcutta team. And this you can see because of sea breeze infusion, it enhanced a sudden growth. Everything went over there and the time available was very minimal. When it fallen down, it never melted out and caused hailstorm in Chennai. Very closer to tropics. Very closer to tropics, we can see that the tropopause is going to be much higher, and your melting layer also is normally not near exactly at 4.55 kilometers. It will be slightly lifted up, and as such, getting a hail is a very difficult phenomena. But there are reported cases where we had hail even at Chennai. So having gone to hail, next we'll go to squall line, where you can see that this is the episode which happened in Delhi. Recently also, similarly, the same 30th May, we got a similar event happened in this year. Both had a similar characteristics, as this is the region where a big squall line happens associated with the western disturbance, or certain times it is differentiated from there. It rolls down from those region, and this, especially this case, it went up to Calcutta. That means it lived near around 1.5 days. More than 24 hours was the life cycle. How this gets? It is because the parent cloud, when it dissipates, it creates a daughter cloud. And like that, when you see to it, though you will not be seeing that multiple clouds generating and going out, you will be seeing as if the line moving like this. This line on the end route, it creates all the devastation, and the driving force is going to be the middle level wind somewhere at 700 FA. And what are the other features is shown there? Nor'westers is a classic example. Similar way, pre-cyclone squall lines also gives an indicator which said the cyclone storm is going to be coming up with. And having covered those small scale events so far up to hail and all those things, cyclonic storm is the major part. You can see cyclone was crossing near to Karaikal, but the devastation was near to Sriharikota. This image shows that the outer spiral bands, which gives much of a water, it may be creating such a large inundation. Here also, when we are using cyclone, we will try to find the center of the system, not with the single method. There are at least 2-3 methods proven as of now on the reflectivity scale, and there are 3 methods in the velocity. All 6 we are using it in near real time, and the system is coming over, and the gross average is taken. This is passed on to our forecasters and the cyclone observers. They see to it and they give a cyclone prediction and alert forecast. So this is everything is documented. It's also available in IMD website. You can have a look to it. And having said as a radial wind, this is a classical example. When the wind goes all around you, you'll be getting zero velocities. This is the case of Cyclone Varda, which had an exact overflow over Chennai. Our radome also faced a damage. Irrespective of the entire damage, IMD kept its commitment to the public. They operated the radar. Given the data, it was being purged irrespective of the entire power shutdown in the city. We operated for near around 3 days with DG sets, and these products were made available. This was of much use. Similar way during Vizag also. A hudud cyclone came, there was a devastation. They tried operating. Unfortunately, there again the radome broke. The entire water entered in. They could not operate as the transmitter was already, the transmitter room was having water, creating a electrical hazard. But of course, those precautions we taken as a lesson in the next, we were doing this. And the cyclone morphology also, we have the features like the Nivar cyclone and the recent Asani cyclone. What happens for certain reasons which the cyclonic storm, the pressure center and the cloud center gets detached off. It is a shear zone which tears that off, and this tearing will give you 2 virtual centers. If you see in the satellite, you will be seeing the cloud center. But the pressure center, by using the velocity thing, we will be getting in the radar much better way. That's how this Asani cyclone recurving also, it was predicted well in time and it was passed on by using the radar at Machilipatnam. So these are the advantages by using a radar. Similar way, these are other examples where the terrain influencing and tearing down the cyclone. That is the Magasan cyclone, which entered into Calcutta region and Bangladesh. We predicted that it will be vanishing in 3 hours. Because of the terrain over there, it happened the same way. And which direction? One, you can see this is the turbulence. The indication of turbulence more, it is going to die down. So we used to give the track. This is the Gaja cyclone track which crossed near Karaikal, observed by Chennai radar. And we can do an impact analysis. If some of your college students are interested to see how the impact is going to be on the seaward side and the landward side. As radar covers the entire periphery, you can see the seaward side, the intensity of the cells are more. Once on the landward side, it is going to be less, irrespective of though it is a cyclone. And now coming over to that, next is going to be the rain applications. From radar, you can derive rain. Rain gauges, we use it normally. Already people might have explained, it is having a very small orifice. It collects the water to it. But radar being a remote sensing thing, you will be getting for the entire volume, it will be covering. Except for this scenario, the adopted algorithm is almost the same. Your radar reflectivity is proportional to the drop size power 6. Your rain rate, it is 4 by 3 pi r cube. You can see that it is proportional to d power 3. That's how Z square, this Z is almost the square root. If you take square root of Z, you will be getting somewhere around R. So what we take Z equal to AR per B, B is going to be 1.6. So that's how from the radar reflectivity, we try to derive rain estimate. And there are again different algorithms. What people used to say, as many number of researchers are there, that many coefficients, that way you'll be getting modified rain perceived. Similar way, the dual pole algorithm also, you have the KDP, ZDR parameters. We can calculate the rainfall to get it to a coarse, precise nature. And this is the way we used to get the products. We say precipitation accumulation product, which is shown in IMD website as a part of the product. And in certain cases, like the sandstorms quoted with this also gives a signature. So that's what which you are seeing over here. And other than this, like non-precipitation echoes also, you'll be getting captured in the radar. These circular downward rings are nothing but, they say, roosters signatures. Morning when the birds, they keep a roosting site, especially for feeding their small ones. They go away from the waterbed near to high top trees. They settle down. In the morning, they make a roundabout path. You can see this circular signature happened near to Delhi at the Noida region. We have the Okla water reservoir. From there, the birds were making that rooster signature. Similar way, there are signatures recorded in Chennai, Maichilipatnam. We have seen to it. And this is a shaft signature. If defense they wanted to carry some exercise which is confidential in nature, they used to drop shafts. Even shafts are now identified by using radar. This is the first signature we observed from our Delhi radar. Similar way, when Korea was disguising and doing exercise, the South Korea radar captured all those things and they issued a warning to North Korea that not to carry a defense exercise. So that way, now these also can be assessed with the radar. But these products which I am showing is derivable only with the IMD. To the public when it goes, these non-precipitable products are of not much interest. We remove it out, only rain and rain related things are shared to public. So this is another signature of smoke. You know, Delhi region, always during the near winter when the harvest is near to complete, they'll be burning the wheat fields. So you got all the circular signatures, the small one, when we analyzed all these things are the regions of the burning fires, and we got those signatures also in that. Having said, whether fog can be detected in the radar, now at present the sensitivity is not to that limitation. We have to go for cloud radars to do it. IMD is yet to procure a cloud radar, but our research sister organization IITM and others, they have a cloud radar using in carbon, they used to sample it. So this is what I feel like saying, and there is a track product. If I know the thunderstorm and I am not a trained forecaster or a radar meteorologist, with the animation, the radar itself can give you a track forecast product, and flood analysis also can be done. And this is still operational in Hyderabad for the entire Krishna Basin. Similar way in Chennai, we have implemented for Adayar Basin, and there are some papers published. And the DGM has constituted a committee saying that there should be a cross-field expertise and it should be displayed with. So this is one of the outcome. You can see over the GIS, we have the cyclone as well as the thunder data sets. You can see the thunder data coming from IITM has been overlaid. Wherever there is intensity of the cloud, the thunders are overlaid. In other regions are thunder free. And the runoff factor can be calculated. This recently got published in the Mausam paper, where we classified for the Chennai event, the entire Adayar river was classified. We ran to it and calculated the water content. Apart from this primitive equations, we went with the hydrological model with the joint work with Anna University Chennai. And now we are continuing the work with IIT Madras under Balaji Narasimhan. So this work is going on. Now the work is not only for Adayar. Having demonstrated in the smaller scale, we thought that we'll be doing it to all the riverbeds, including taking into the feature of the city. We thought in the smart city campaign, we will be giving a very close level output on pilot basis to study for the initial 2 years. Once it is proven, this will be made operational everywhere. That means on the road, you will come to know how much water is likely to accumulate on the road once we create a flow map. These are the results. You can see that we made a model, 2D model, and the water accumulation. This was verified with the Bowen website, and on the site where literally the student went there, he verified why the flooding was happening. And most of the flooding in urban, you are so sure it will be happening only because of those mishandling. All these things with that, it has been caught in. And this warning is R alert. This is one operational within IMD. If a person is not there in radar to brief, taking the radar data by using open source Python libraries, it will be calculated and giving an alert to a particular region or a particular district or to a particular location. It creates an alert and gives in red and green. Green means safer, red means yes, there is a probability of severe thunderstorm. And along with that, it gives out a message also. It is sending us a message to the classified users in the form of an email, or it can be sent in the form of a Twitter handle. Similar way, we have a probabilistic forecast. I had some few images. With the few images, I wanted to know what will be the impact in the next region. So that way, this probabilistic impact has been shown at 30 minutes how it is going to be, and how the light rain, whether it is going to be or heavy rain is going to be. This has been implemented in Visakhapatnam on trial basis. The trials are going on. Once it is proven, not only on the exact observable data, we will be using our own algorithms and calculating the probability of the clouds moving ahead. And this is the validation which was done up with. And one more thing, instead of going for the proprietary where we thought we will use the open source libraries to plot it and we can shift it out. You can shift it across the airport, or you can put it over the dam or over the city. Then ultimately people will have a feel to it. This again I will be touching back later. One is storm flag, you can classify. by using fuzzy logic and other thing. Now the classification is there. Same way we used to do a classification, differentiating different clouds into the same segment, and each cloud will be tracked for its movement, and forecast track will be given. Not only on the basis of giving, it will be giving the future state in the form of an email for this thing. This has been contributed from our team from Goa. And this is the off-centered maxZ, where you can see that if I'm interested in studying this region, which is rounded in the left of the image, you can see it has been taken up with. I'll be getting the cloud height, including the region of the cloud cover. So this also has been done. Now there is a request from our IGI, Delhi Airport. They wanted a similar product to be done for their use to predict about the hazardous weather. The process is going on. Not only said that, this locust which was set there, when there was a very severe demand to find out the locust spread and wide, we tried with radar. Of course, when we succeeded and presented in the form of the paper, subsequently the locust spread was not there. But this algorithm is already available for to be used. If the next attack is there, with using our weather radar, we have the signatures to grab it and put. This paper is available in ResearchGate also. We uploaded to it, and these are the studies to show how the spread of the locust was there and how it got a signature in the radar. Normally, you can see only up to 1.5 kilometers it is there, but this much high reflectivity going somewhere up to 45-50 dBz will normally happen only in hailstorms. But this locust density was so high, that's how we got it. We are in the process of validating with the exact videographic reports taken by our locust warning office. So I will conclude with this, and there are some more work which can be shown up with. This is the 3D view also which we created, which is still on the pilot mode. This will be coming up with. I am open for questions if any.
Thank you, Kannan sir, for the informative lecture on the topic of radar. May I now request the viewers to ask any of the questions related with the radar topic which has been discussed today. One by one, viewers may ask, or you can ask in the chat box also, or can also email to Kannan sir for getting your doubts cleared. I presume viewers have no doubts at present. They may raise their doubts in the respective mail ID of Dr. Kannan sir. May I now switch over to Sri Savai Sajay sir to express the vote of thanks.
Thank you, Rajiv. I thank Dr. Kannan for this very excellent informative lecture, and the audience may be feel free to contact anytime on his email address, which will be given by us for your doubts. One question has come up by Shubham Verma. He is asking any experiment going on for remote operation of radar in India. Kannan?
Remote operation of radar at the Himalayan terrain, few of the radars we were not exactly posting staff, as the locations are going to be quite difficult to reach over there. We were experimenting, especially in Leh. There is no manpower as such available. Like that, there are few Himalayan terrain where we are keeping without a manpower. But what we observed is, still being a developing country, the power fluctuations and other thing requires at least a person to be there, though need not be a radar meteorologist, who will be knowing a little know-how to see to that if whether there is a power failure or any other events which is leading not to give a power to the system. So if such a thing happens, a manpower from there, he can give an alert. All the radars which IMD is having, they have the capability to be operated on remote. But owing to this only reasons, we are posting staff and keeping a very thin staff strength in most of the radar locations. In some of the radar locations, as rightly the gentleman has asked, we have very minimal staff, contract staff also.
Any questions? Still any questions from viewers? Okay, thank you from Sabita. She has told you. Thank you, sir. Any questions? Again, you can write in the chat box.
Savaiji, probably no, this is the first talk. Mostly they may not be having. You can spread out my email to most of the people. If they are having some specific interest on a study, either hail or some disaster event in their vicinity, they can approach our radar lab at Delhi. They can address a mail to radarlab@gmail.com. From there, the mail will be branching out. We have a radar application group. They also will be in a position to help it out, either to jointly work or assist the researcher. Then we'll be getting much go ahead very closer to the field. As we did in Chennai, we had association with much of the research institutes. Now we are trying for a tie-up with the IIT Bhubaneswar. Similarly, Amity University Delhi also has come up for a tie-up. Similarly, if the other institutes, if they feel like working with the high resolution radar data sets, they are quite welcome. IMD is already having a plan. Earlier they floated. Now it is not there with the project funding was there. But again, it will be coming up shortly where they'll be getting a funding also if they are doing an intensive product, which will be of much use for the common man. Thank you.